Okay, I think it's nearly 15 past. There's another minute or so. I saw one question in the chat that was about the PowerPoint slides that are online. I updated some of the slides yesterday evening, and it's possible that I only updated the PDF version and not the PowerPoint version in the Dropbox. So if you don't have this current slide and you want to see it for yourself, have a look in the PDF version, and I will update the PowerPoint version after today. Okay, then let's continue. So far we have started the compile process for the release mode, and we had a look at the free surface model. But at this point, I want to first take a quick look into the free surface model and how it looks like. And then we will talk about how to change this model beyond the parameter file. So I prepared the output for this model already yesterday. That is why I already have it inside of this directory. If you ran it over the break, maybe it's still running, it takes a bit of time, then you could follow along and do the same on your virtual machine. But if you haven't, then don't worry. We'll run the other model, which is very similar later. So I will do the same we did yesterday. I will go into the output directory of this free surface model, which is called output free surface. And then I will open Paraview with the solution.pvd as argument, which will immediately load this output file. And when I click apply, then it will show me the model size. And if I switch the visualization from a solid color to the temperature in the selection box, then I will see this circle that I talked about earlier. This circle of higher temperatures, 200 Kelvin, versus the background of 0 Kelvin, whatever that means. So it's not actually 0 Kelvin, but it's a 0 temperature background. If I run this model over time, then you can see that the blob rises towards the surface. And I promised you a free surface, but if you take a look at the boundary, it's actually very hard to see if the surface is actually deforming. So we'll use a new feature of Paraview that we haven't discussed yesterday. And that is, if I click on this little wheel in the top part of the properties panel, it toggles the advanced options. And it creates lots of options, but among them is a subsection that's called transforming. And this allows you to scale or translate or rotate the figure that you see. And in this case, I want to scale the y-axis by a factor of, let's say, 20. So it's the y-axis because we have a 2D model, and Aspect always uses x, y, z coordinates, meaning in a 2D model you have x and y coordinates. Although in geology we are often used, or in tectonic modeling, we are often used to using x and z because our second dimension is usually the depth. It's still y for Paraview and Aspect. So if I set this to 20 and then either press enter or go to another window, you see that the model is suddenly scaled in Y direction out of the screen. So I can click on this little reset button in the top row, the 4 arrows that show in all directions, to reset the model size so that I can see everything. And then I can scroll in with the scroll wheel towards the top boundary and take a look at the top boundary. And you can see that the surface actually deforms on top of this blob. This becomes more clear if I switch the display to surface with edges, which shows the mesh. And if you go zoom in closer, you will see that the surface is actually deforming above this blob. This is what we wanted to see. Okay, but the main point of today is actually not looking at the free surface, but on modifying this beyond what is possible in the parameter file. So let's look into that. And for that, we are going to use something that's called a shared library or an additional plugin for Aspect. So sometimes if you want to set up a model, you cannot find input parameters that fit whatever setup you have in mind. And in order to fix that, it is possible for you to add features to Aspect without actually modifying the main Aspect code. And you can do that by creating additional plugins. We already talked about plugins yesterday. I will quickly remind you of that today. But if you have this additional plugin, they can be loaded into Aspect when you start your model, and then you can use them during the model run. And we will use such an additional plugin at the example of the other parameter file in today's folder, the free surface with crust model. So just a quick reminder, Aspect has this core part, which is called simulator. And this core part interacts with a lot of outside plugins that change behavior of the simulator. And all of this is written in C++, and it uses an object-oriented design and some pretty advanced language features of C++ to keep all of that manageable, even though it's so big and has so many features. In order to change the simulator part, or actually any plugin, you need to understand some C++. But if you want to just change one of the plugins, that is much, much simpler than going into the core part and changing something about the simulator class. So what are these plugins? We talked about them quickly yesterday. All of the initial conditions, the boundary conditions, even the geometries are individual plugins. The material models, definitely all of the post-processors, and so on. And you also already learned about how this looks like in the input file. In the input file, we have many parameters that are called set model name or set list of model name, and that is then normally followed by the names of the plugins that you want to select. And then there are additional subsections that group all of the parameters of these plugins. Now, let's take another look inside of Aspect's repository and let me do this inside of the virtual machine, because if you open a file manager or explorer and you take a look inside of the Aspect directory, then there are two directories that contain most of Aspect's source code, and that is the include directory and the source directory. So these two directories actually contain the source code of Aspect. The include directory contains the headers, the source directory, the actual source code. If you go inside of the source directory and take a look at the directories that are here, then these directories directly resemble the subsections that you have in the parameter file. So for example, there is an initial temperature directory, which is equivalent to the subsection in the parameter file that's called initial temperature model. And there's a geometry folder. If I take a look into the geometry folder, then I'll see that there are different files, and these files are called box, chunk, sphere, spherical shell, and so on. And these files exactly contain the plugin that corresponds to the subsection in the input file that is called box or spherical shell or sphere. So the structure of aspect source code is actually very similar to the structure that you see in the parameter file. And so what we are going to do today is nothing else than using a model that uses an additional plugin, like a new CC file for a new plugin that is not inside of the main aspect, but that is inside of the directory of the model that we are going to run. So let's first take a look at how this looks like inside the parameter file. I already mentioned, so let me clean this, and I'm still in the directory that we were in before. So I'm still inside of this directory, which is Aspect Tutorials 2020 Tectonics Modeling Tutorial Session 2. Actually, let me go outside of the output directory I was still in. So I'm inside of this directory, Session 2, and there is a second parameter file in this directory, which is called freesurfacewithcrust.prm. We are going to take a look inside of that parameter file for now. This is essentially the same model as the free surface model, except it has a crustal layer on top, which means it has a layer with a higher viscosity at the surface. And it creates this higher viscosity layer by using such an additional plugin. So let's take a look at how it uses this additional plugin. In this parameter file, only the parts that deal with the additional plugin are commented. Everything else is the same as in the parameter file we looked at before. The first additional parameter is right here at the top. It's called additional shared libraries. And it is set to a file path. This file path is inside the current directory, inside the plugin directory, and the file path is called libsimplerwithcrust.so. And we will take a look at how to create this plugin next. Apart from this, the parameter file is exactly identical to the one that we looked at before, except for the material model subsection. In the material model subsection, we now select a different model name. Instead of simpler, we select simpler with crust. And if you would try this in a default aspect installation without the additional plugin that we loaded at the beginning of the parameter file, it would fail. It would complain that there is no plugin that is called simpler with crust. But we will provide it for this model. And this simpler with crust material model has new input parameter in its subsection, simpler with crust model. It has input parameters like lower viscosity, upper viscosity, and jump height. And we will take a look at where that comes from. So next, let's take a look into this plugin directory. So remember, we're in the session 2 directory. And if I go inside the plugin directory and take a look, then there are exactly two files. One file is called cmakelists.txt. This is a file that tells Aspect how to compile the plugin that is inside of this directory. And there is a file that's called simplerwithcrust.cc. And this file contains the source code to run this additional plugin. Can I quickly ask for how many of you compiling the release mode has already finished? So could you quickly send a yes or a thumbs up if your compilation has already finished. Okay, I see some no's. Yeah, that's important as well. If you haven't finished, then please put up a no so that I know that. Okay, it looks like there are quite some for whom it hasn't finished yet. So, okay, then let's wait before we continue with anything that requires the release mode. So let's take a look into this simpler with Crust CC file to see how these plugins look like. So today will not be a full coding tutorial for Aspect. This is only to show you what to expect if you would take a look, and some small changes are actually very simple to make, and you don't need to know very much to make these changes. So again, I'm going to use LeafPad. In practice, you probably want to use a proper integrated development environment, or at least an editor that highlights the different words or the different keywords of C++ in different colors. That's an enormous help if you program often. Actually, let's do this. So I didn't use the LeafPad editor now that we used before. I decided that it's simpler to show you this in an editor that is actually made to code, which in this case is called Visual Studio Code. You can do the same if you, instead of LeafPad simpler with Crust.cc, you can use code space simpler with Crust.cc. And this editor is actually much more than just an editor. It's an integrated development environment where you can program and that you can use regularly to change programs. But the main point at the moment for me is that it has different colors for different keywords. So if you take a look into this file, or in any file of Aspect, actually, you will see that there is a copyright notice at the top. Then there are some include files of other files that are needed inside of this file. And then usually everything that happens in something that's called namespaces. None of this is extremely important right now for a tutorial. It's of interest maybe later if you want to make more wide-changing changes to Aspect. Now let's see what happens inside of this model. Just a broad overview. Inside of this CC file, there is something that is called a class. And this class is called simpler with Crust, just like the file name and just like the plugin that we are going to use in the parameter file. And this class, no matter whether you have experience with objective oriented programming or not, you can, for now, it's enough to think of a class as a collection of several functions. If you have programmed in any language so far, you have likely encountered functions. And you can, for now, just think of a class as a collection of functions. And this class has a few functions. One of them is called isCompressible. And the use of this function is determined whether this material model describes a material that follows a compressible equation. Another one is called reference viscosity. This is an internal function aspect that helps us to scale the equations to more accurately solve them. None of those are very important for our purpose at the moment. One is called evaluate, and this one is important. This one gets some input from the main simulator class, and it has to compute some output. And we will take a look into this input and output. But you can essentially think of the input as the current model variables, so things like temperature and pressure, and the output as the material properties, so things like density, thermal expansivity, and viscosity. And then there are two functions that you encounter in essentially every Aspect plugin. They are called declare parameters and parse parameters. And these are the functions that are responsible to work with the input parameter files. The declare parameters function describes what kind of parameters in the parameter file are allowed. So if you put in a random set some parameter equals to something, then Aspect will complain because nobody told it that some parameter is actually a valid parameter. So this is the purpose of the declare parameters function. And then there's another function called parse parameters that can actually read the parameter file and translate what it finds in the parameter file to the value that is used in the model. So you can think of this as a conversion function from the string in the parameter file to whatever is stored inside of the model. In this case, actually mostly double numbers that you can see down here. So far, we have only seen the names of these functions, which is called a declaration in C++. Below this, there are the actual implementations of these functions, so what these functions do. In the case, so we can maybe most simple explain this at the example of the isCompressible function. Don't worry about all of these keywords. For now, it's important to see that this is the isCompressible function, and that the only thing it does is it returns false always, which means this is a model that describes an incompressible model. It is not compressible. If you take a look at the evaluate function, it becomes more interesting. So this function obviously has something to do with viscosities, densities, thermal expansion coefficients, and so on. And this is the main function that computes the material properties that are used in the equations that we discussed yesterday. So in this case, you can already somewhat guess that this if-else statement has something to do with the viscosities being one value, namely eta u, if we are above a certain height, and another value, namely eta L, if we are somewhere else, not above a certain height. And then there are other properties that are set here. So this is the main function that you would want to change if you want to change any material properties in this model. And we are going to come back to that once we start discussing of how to change this plugin. But for now, let's move on to the declare parameters function. If you take a look at the declare parameters function in any Aspect plugin, they will all look similar to this one. They will start by having a call to a function that's called enter subsection, and then a string here, like material model in this case, that defines the name of this subsection. In this case, we enter the subsection material model, and then we enter the subsection simpler with crust model. And then there are several calls to a function that is called declare entry. And as the name suggests, each of these calls tells Aspect that there is a parameter that is called reference density inside of the subsection material model, subsection simpler with crust model. And then it tells it a few more things. It tells it the default value of this parameter. It tells it what kind of pattern we expect for this value. So let's say if I would write an input file that says set reference density equals to A, then Aspect would complain because A is not a valid pattern for a double. It cannot be converted to a double, and it shouldn't. It should crash with the message A is not a number. And this is exactly what would happen. And the final parameter for this function call is a documentation string for this parameter. So a longer string that explains what do we mean by reference density. And this pattern is the same for any parameter that is declared here in this parameter model, or actually in any aspect plugin. So we have other parameters that are called reference temperature, lower viscosity, upper viscosity, and so on. And finally, after all parameters are declared, there are two calls to a function called leave subsection, which essentially tells this function or tells aspect that we are now leaving the subsection simpler with crust model and material model, and that we are done declaring parameters. Finally, there is the function called parse parameters. And parse parameters is structurally very similar to the declare parameters function. It also has these calls to enter subsection and leave subsection. And inside of these calls, there are calls to functions that are called get double in this case. So this function is this conversion function that I talked about. It will look through the parameter file. It will search for the parameter reference density inside of the subsection simpler with crust model, inside of the subsection called material model. And if it finds this parameter, it will convert it into a double, and then it will store it inside of this C++ variable called reference density. So this is the process where the file is actually converted into a variable that can be used inside of the program. I am, in case one of the organizers is currently thinking that's not quite correct, that is true. It's a bit more complicated than what I just said, but the model is essentially correct, like what I just said. So these two functions, declare parameters and parse parameters together, allow you to use the term reference density in the parameter file to assign a value to it, and then to allow this plugin to actually use this reference density for something, for example, in the function evaluate that we saw above. So reference density, which was read in below in the parse parameter function, is used here in evaluate to compute a density. This is how far I wanted to go with explaining this plugin for now. Next, we will run this model, and then after that, think about how we could change it, or what interesting things we could do to this function to make it somewhat more realistic or more to whatever we want to do with it. But at this point, I wanted to quickly check if there are questions that we should discuss, if there's something that I didn't explain well enough.
Yeah, so I guess my basic feedback would be not everyone is familiar with how C++ works. And so some of the things that you show in this file are a bit confusing if like.
Yes, and I on purpose didn't explain everything that was in this file. So don't worry if you don't understand some things in this file. That's completely normal. And we don't really want to make this a programming workshop in C++. For example, don't worry too much about the concept of what a class is, or what this weird dim parameter means here, or what this template means over there. The important part of these lines is essentially that there is a function that is called evaluate that there are two things that it gets that are separated by a comma. It's in and out, and that, as the name says, it gets input parameters in and has to compute output parameters in out. This is about the level of detail that is of interest for us at the moment. Okay.
Could you potentially quickly review different data types? So there's a question about like double versus int and things like that.
Sure. So this is not really a C++ question. It's in all programming languages. There are different, except of course things like Python, where things get a bit muddy. So in C++ and in many other languages, each thing that you want to store or each variable that you want to work with has to have a unique type. That defines how it is stored in memory. So a double, for example, is actually what double stands for is a double precision floating point number. So ignore the double precision part for now. It is a number that can represent any number with a floating point. So it's not a natural number. It's not an integer. An integer is in essence an either positive or negative natural number. And a double is any number that you can represent in floating point presentation. So anything like 3.5 to even approximations to irrational numbers like pi. So it's not exactly pi, but it's very close to pi. And in this example, we only, so in this example model only uses double parameters. All of these parameters are any floating point numbers. There could be other data types. In this example, we use some complicated data types that I don't want to explain right now because they are more confusing than I would explain with that. But for example, the isCompressible function uses a data type that's called bool, and this data type can only be false or true. It's a 0, 1 data type. I think this is all what is important to talk about types right now.
There were also some questions in the chat about the ordering of when you declare functions and whether or not that is important, and then also the reference viscosity, but I'm not sure if we want to wait to talk about the reference viscosity.
Yeah, I think so. The reference viscosity is something that we may want to talk about at a later point or in a discussion round after today's lessons. It's most often it's not important. In very few cases, it's important. The ordering of functions doesn't really matter in these files. So I could take this declare parameters function and remove it from here and put it up there, and it would still work. We have a convention, an aspect that the declare and parse parameters functions are usually the last ones in a file. So they are usually pretty at the end of a file, but this is a convention. It's not necessary. Okay. If there are more detailed questions about the programming, we can discuss that in a discussion round later. This shouldn't be, as I said, this was not intended to be a programming lesson. I put in one slide into the presentation for today that describes some common functions that you will encounter in many aspect plugins. We, in this plugin, saw the evaluate function, and we saw the declare parameters and parse parameters function. There are two other functions that you will encounter pretty often. They are called initialize and update. Initialize is usually called once at the beginning of a model run. Update is usually called at the start of every time step. but that is not something that we will need today. And finally, if you look at any aspect source file and you are confused by something that you see, for example, some name that we use that is somehow related to aspect, but you cannot seem to find what it means or what you can do with it, there is a developer documentation on our webpage that can probably help you. And let me show you how you would go about finding something there. So if you open a web browser and you go to Aspects homepage, which is aspect.geodynamics.org, there is a tab in the top panel that's called Development. And if you click on the Development tab and then click on the Documentation tab, you will come to a page that will allow you to scroll essentially through all of the explanations that we put into these source files. So this documentation is actually generated from Aspect source code. And the neat thing about it is it has this search window at the top right. And so let's say you found something in the parameter file, in the source code file, in the .cc file that we looked at, that confuses you. Let's say you found a declare parameters function. Then you can put in this name in the search window, and you will find lots of declare parameters functions here, and you will see all the places where they are used. In this case, that doesn't help you very much. But let's say you noticed that there was something that is called material model inputs in the evaluate function. So just as a reminder, if we go to the evaluate function, the one that actually computes the material properties, this one gets a variable that's called in, and it has this weird type, which you don't really know what it means and what it can do. And it's called material model inputs. So if you then search for material model inputs in this developer documentation, you will see that there are two places, or let's say it gives you two possible answers. One answer is all the places where material model inputs is used in some form. The other one is aspect material model inputs, where this is actually defined. If you click on that, then it shows you all of the things that are, all of the things that are related to material model inputs. And for example, you can see that all of the public attributes, don't worry for now what public attributes means, but that apparently it has position, temperature, pressure, pressure gradient, velocity, and so on. And if you then take a look at how this variable is used inside of this function, so if you take a look at how is in used inside of this function, you will notice that, for example, here, it is used as in.temperature, and then a certain index into this temperature. And from that, you can guess that you could just as well have written in.pressure something if you want to access the pressure, or in.velocity if you want to access the velocity. So this is a way how the developer documentation can help you find out more about things that you don't really understand when you read the code. Okay, that's all I wanted to say about this, because again, we don't want to spend a lot of time on writing aspect code. We want to spend time on building aspect models. Okay, so now we know that there's this additional plugin in the subdirectory, and we want to use it for our model. So for that, we need to compile it, just like the normal aspect source code that we compiled before. So let's do this. In the virtual machine, so first of all, I will close this editor. We don't need it at the moment. And I will also close the developer documentation. And remember, we are inside this directory. So we are inside the session 2 directory, inside the plugin directory, which is the directory that contains the CMake lists.txt and the simpler with crust.cec. We use exactly the same process to compile this plugin that we used when we compiled Aspect. So we first need to use the program CMake to create the compile instructions. And in this case, CMake needs to know exactly one thing, or well, let's say it needs to know two things. First of all, it needs to know where's Aspect, so that it knows how to compile this plugin with the same instructions with which Aspect was compiled. And secondly, it needs to know where is the source file of this plugin, which is simple in this case because it's exactly in this folder. So the way to tell it where Aspect is to use the -D and then Aspect underscore dir equals, and then the path to Aspect. So in this case, that would be the home directory /Aspect /, and then the directory that contains the information for how to compile Aspect. So we put that into Aspect /release in our case. If your release build has not finished yet, then don't worry. You can just as well use build for the debug build, or you can just say you use release anyway, and you will wait with running this model until it has finished compiling the release mode. Both works. And the second argument is simple. It's a simple dot, which means this directory contains the plugin that we want to compile. This parameter can be confusing because you need to take care that you capitalize this correctly. So it's a capital D, a capital A, then a minor SPECT underscore, and then a capital DIR, and then equal the path to the Aspect release directory. And if you run this, you will see similar configuration messages that we saw earlier when we compiled the release directory. You should see that it says release mode here, and it should also say using Aspect dir and then the path to your Aspect directory. If you had a typo in your parameter up here in the Aspect dir parameter, then it's possible that it will find the other Aspect directory, not the release directory. In that case, you can simply try again, correcting the typo in your original instruction. And it should then find the release directory. After you have done that, just as you did for compiling the release mode, we can also use make to compile this plugin. You can just as well use make space -j and the number of processors in your virtual machine. But in practice, for the plugin, it will not matter because there is just a single plugin file, and it will be relatively quick no matter how many processors you use. If you have problems at any step here, then please post them in the chat. This is relatively important for the rest of today's session. So I would like to make sure that everyone got this step. Okay, it seems like it worked for most of you. So I'll slowly continue, and if you are stuck, I will have these instructions on a slide during the next break. So now we compiled this additional plugin, and if we take a look inside the plugin directory, then you will see that now it not only contains the CMake lists.txt and the simpler with crust.cc that it had before, but it will also contain the file called libsimpler with crust.so. That is the file that we saw earlier in the parameter file in the additional shared libraries parameter. And it contains an aspect link, so a link to the aspect binary. This is very useful if you have several aspect versions on your computer and you don't remember which one you used to compile this additional plugin. This aspect link will always point to the aspect binary that you used to compile this additional plugin. So to give you an example, we currently have two different aspect binaries inside of this virtual machine. We have the one that runs in debug mode, and we have the one that runs in optimized mode. If you would start this model, so the free surface with crust model that we are going to start next, with the wrong aspect version, so a different binary than the one you used to compile this plugin, then aspect will crash. It will give you an error message that is something like, probably you ran this model with a different aspect version than you compiled the plugin with. So that's useful. But if you always just use the aspect link that is inside of the plugin directory, then you should never run into this problem. So let's start this model because it will take some time to finish. So just as a reminder, we are inside the session 2 directory, and we have compiled the plugin inside of the plugin directory that is inside of this session 2 directory. So to run aspect, first of all, we would like to run this in parallel today because it will take some time. And that means we will use the mpi run command with the parameter -np and then the number of processors that you have available inside of your virtual machine. And I will use 6 at this point to be finished quickly, but you can use whatever number of processors you assign to your virtual machine. Next comes the binary of aspect that we want to use. And I just said it's safest to just use the one in the plugin directory because that's the one that was used to compile this plugin. So the path to aspect is actually ./plugin/aspect. And then, as usual, the next parameter for aspect is the parameter file that we want to start. And in this case, that is free surface with free underscore surface underscore with underscore crust.prm. I will leave this command up for a bit just so that you can see it, because as soon as I execute it, it will be gone with a lot of output on the screen. So the command is mpi run -np, whatever number of processors you have available, ./plugin/aspect, free surface with crust.pm. I'll execute that. and then it will start running this model. The first time steps will take a while. They're not very fast. It will get faster over time, but it will take several minutes to complete. If you have not finished compiling the release mode, as I mentioned, you could have compiled the plugin with the debug mode by replacing the cmake command that links to the release directory with the cmake command that links to the debug directory that was in the virtual machine already. And in debug mode, this model will take about 30 minutes to run on 2 cores. In release mode, it is about 4 minutes. So this is a good time to take another break, to wait for the model to finish, and to continue in about 10 minutes. So 15 past the hour or 45 past the hour in India. And I will leave up this slide that contains the informations for how to compile the plugin and for how to run the model. And after the break, we'll talk about, first of all, the results of this model and how to change the material model to do other things than just adding a high viscosity layer at the surface. If there are any questions about this part, then now would be a great time to post them in the chat. And otherwise, I'll see you all in 10 minutes.